Hello friends, in this video we are going to discuss what are beats, and also we are going to discuss about the superposition of two collinear harmonic oscillations and differing frequency slightly in frequency, so that the number of beats produced per second is equal to the difference of their frequencies. So that's what we're gonna discuss in this video. So before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. Okay, and if you want to follow me on Insta, this is my Insta ID OJHALAKHYAZIT123. this is my Insta ID. Okay, you can follow me on Insta. So now let's start. So first let me write what is a beat, what are beats. Okay, so when two sounding bodies of nearly same frequency, I'm not saying that exactly same frequency, nearly same frequency and amplitude are sounded together, then the resultant sound consists of alternate maxima and minimum. Okay. So when two waves superpose like this one and this one, two waves slightly different frequencies and amplitude, then the resultant wave will be something like this. Sometimes it will be very high, then again it will be very low, then again high, right, like that. Okay, so that is called beat. Okay, now you see, let us discuss the analytical treatment. Let us consider the displacements equations of two waves, due to two waves, suppose displacements y1 and y2. Okay, due to two waves, due to two waves suppose both waves are in phase, due to two waves in phase. Let us consider, for simplicity, they are in phase. Okay, at any point, we suppose like this: y1 is equal to a sine omega 1t, and y2 is equal to, suppose, b sine omega 2t, where a and b are the amplitudes. Okay, then here omega 1, which is angular frequency, that is equal to 2 pi nu 1, where nu 1 is, suppose, the frequency. Nu 1 is frequency. Just wait, nu 1, and let me write omega 2 is equal to 2 pi nu 2, and let me mention here, nu 1 and nu 2 are the frequencies of the two waves, and we have considered that their frequencies are slightly different. Nu 1 minus nu 2 is, suppose, very small. Let me consider that way. Okay, just let me write this one in same phase. Let me write this one in bracket. Okay, at any point in the medium, in the medium at t is equal to 0. Let me mention this within the bracket. Okay, so hope you have understood this. So these two equations can be written using these two terms, right? Instead of omega 1 omega 2, we can write 2 pi nu 1 and 2 pi nu 2, right? If we write these two equations in terms of nu 1 and nu 2, then what are we gonna get? Let me replace this omega 1 and omega 2. 2 pi nu 1, here we have t, and 2 pi nu 2. So these are the two equations. Okay, this is suppose equation number 1 and this is suppose equation number 2. Let me consider that. The resultant displacement will be given by, then in that case, y is equal to y1 plus y2, right? So that's going to be equal to, so we have to use these first and second equations here. Okay, this is y1 and this is y2 here, so we have to add these two, y1 and y2, right? Hope you have understood this. So in that case, what we're going to do here, okay, so now you see we can do one thing. We can write this nu 2 as we can express this as nu 1 minus nu 1 plus nu 2, right? Nu 1 cancels, again we're gonna get nu 2 here, so we can express like that. Okay, if we do so, then what we can write here, just let me copy this here. Okay, then plus b sine 2 pi, and we can write nu 1 minus, if you take common nu 1 minus nu 2, that's what you can write, okay, into t, right? So I have written nu 2. If you open this bracket, nu 1 will be cancelled, again you're gonna get nu 2. That's it. Okay, as simple as that. So now we're gonna use the trigonometric identities, a sine a minus b. If we use that, then what we're gonna get, then y is equal to b into here within bracket, what we're gonna write, sine a, here sine a is sine 2 pi nu 1, then cos b is here cos 2 pi nu 1 minus nu 2. Okay, we are applying sine a minus b formula, sine a and b. Okay, so sine a cos b, then minus cos a sine b, here again cos a 2 pi nu 1, here we have 2 pi, right? So we're gonna get we're gonna take 2 pi nu 1 as a and 2 pi nu 1 minus 2 as b. Okay, then sine b is your 2 pi nu 1 minus nu 2. That's what we have got. Bracket closed, then outside it we need to put t here. So hope you have understood this. Now let me copy this result and let me go to the new slide. Okay, just let me take a new slide. Let me copy this result. Okay, so here is the new slide. This is the last result we have got. So now what we can do, just let me simplify this. Right, sorry, I missed the t. Actually this t is multiplied with this, right? So that's why we have to put here t and here also t. Okay, here also we have to put t. Similarly we have to put t here as well, and okay, just wait, let me write this t inside the bracket. Okay, so hope you have understood this. Actually the sine a, when we say sine a, 2 pi nu 1 into t will be sine a, and a minus b will be 2 pi nu 1 minus nu 2 into t. That should be considered as b, right? Hope you have understood this. So Now here also we need to change it. This t should be right here, there should be a t, and okay, here also we need to put t, here also t, then just to give me some space. Okay, here also we need to put a t, right? So then what we have got, t, then cos 2 pi nu1 minus nu2 t, then minus b cos 2 pi nu1 t, then sin 2 pi nu1 minus nu2 into t, right? That's what we have got. Okay, so from here what we can take common, let me check. Okay, so here you see sin 2 pi nu1 t and sin 2 pi nu1 t we can take common from here, right? That's it. Then and what we can do, okay, just give me a second, just wait. Okay, done. So here we have taken common a sine, so a is not common here, sorry, sine 2 pi nu1 t is taken common. Then within bracket we're gonna have a plus b, this red underline terms are taken common. Then cos 2 pi nu1 minus nu2 t is taken common, right? Sorry, just give me a second. Only this t is taken common, not this one. Okay, there must be a t. So now let me rearrange these terms. Okay, then minus, let me write cos 2 pi nu1 into t first, then within bracket b, this and b into this sine 2 pi nu1 minus nu2, that's what we have got into t, right? So now let me copy this result and let me take a new slide again. So this is the result we have got. So from here what we can take, we can consider here this term, this is within that within bracket, as we're going to take this one as a cos theta, and this term within bracket we're going to take this one as a sin theta. Okay, so here a going to be the resultant amplitude. Okay, that capital A, we're going to take capital A, this term. Let me copy the terms within bracket, so there should be a bracket. Okay, okay, now here you see, so here we're going to take this is as a cos theta, taking this one as a cos theta, then this part, let me take this part, we're gonna take this as a sin theta. So here we have considered that a, this capital A is the resultant amplitude, this is the amplitude of the resultant wave. So if we use these two in above equation, then this equation is will be of this form: sine 2 pi nu1 a cos theta minus cos 2 pi nu1 t, oh, sorry, I missed it, the t here, then a sin theta. That's what we have got, right? So now you see from here, okay, So if we take this a common, right, then this this a should not be written after taking common, so we will get this. So what do you observe from here? You can see this is sine a cos b cos a sine b, so that is sine a minus b formula, right? So that's why this can be written y is equal to a sine 2 pi nu 1 t minus theta. So this is in sine a minus b formula. So this is equation number 3. So this is the equation for the resultant wave, right? That is what we have got, and this is its frequency. Okay, so hope you have understood this. So now let me copy this and let me go to the new slide. Okay, so here is the equation number 3 that we have got. Now what we are going to do, now you see, if we divide these two, here you see this one by this one, okay, then what you gonna get? Just let me copy this. You see, if we divide these two, just wait, let me write this two here on this side, and let me write this way. Just give me a second. Okay, this is what we're gonna have after dividing this one by this one, right? Hope you have understood this now. So this a gone, here we have got tan theta, right? Tan theta equal to this. Okay, so from here we can determine theta, right? From here we can determine theta. And how to determine a? How to determine a? So now you see, a can be determined by squaring and adding these two equations, right? If you square and add these two equations, then you can determine a. Okay, so let me write here a square cos square theta plus, if you square this, then what you gonna have? A square plus b square cos square 2 pi nu 1 minus nu 2 into t. Okay, then minus twice plus twice ab. So here what we're gonna have, 2ab cos 2 pi nu 1 minus nu 2 t. That's what we're gonna have. If you square this one only, right, that means this one. If you square both sides, this one, right, then you're gonna get this. So similarly, squaring this second one, then what you gonna get? Let me show you. So let me use another color. A square sine square theta is equal to b square sine square 2 pi nu 1 minus nu 2 into t. That's what you're gonna have. Now let us add these two equations. So on adding these two equations, then what we gonna get if we add these two, right? Just give me a second. Hold on, let me adjust these terms. Okay, little bit of adjustment. So here we're gonna get this. Okay, oh sorry. Okay, let me write this one here, and we are adding squaring and adding these two. So on the on the left hand side, we will get this one square plus sine square a, right? This is what we have got on this left hand side. This is the left hand side and this is the right hand side. So what we have done, we have squared these two equations and then we have added these two. then we have got this, right? So now what we can do here, you see, if you take this a square common, then within bracket we're gonna have sine square theta plus cos square theta, that's gonna be 1. So that's why, that means this one will be of this form. Let me show you how. That will be a square within bracket cos square theta plus sine square theta, right? Within bracket we're gonna get cos square theta plus sine square theta, which is equal to 1. So that's why here we're gonna get a, we're gonna get capital A, right? Hope you have understood this. A square, not only a. And similarly here you see, if you take b square common from these two, b square common, within bracket you're gonna get cos square 2 pi of this and sine square 2 pi of this. Again we're gonna apply this identity sine square theta plus cos square theta 1, then 1 into b square, you're gonna get b square. So that's why what we're gonna have, let me write this on taking b square common. So we're gonna left with this term only, so this remaining parts become 1. So here just wait, just we have got b square only, right? Hope you have understood this. So on taking b square common, b square is taken common, right? Then within bracket we have got cos square 2 pi nu 1 minus nu 2 into t, then plus sine square 2 pi nu 1 minus nu 2 into t. So sine square theta plus cos square theta, that's going to be 1, then we're going to get b square only. So a square becomes this, right? Hope you have understood this. So if a square is equal to this one, then a will be equal to root over this, right? Hope you have understood this. So let me take, this is equation number 4. This is suppose equation number 4. Just wait, let me write, this is 4 and this is 5. Suppose this is equation number 5. Hope you have understood this. Now you see, let me write what we have got 4 and from 4 and 5. Let me write that one here. So from equation from equation 4, okay, it is evident that the phase angle theta changes with respect to time. If we go back to the previous slides, here you can see this theta will be changed if this if you change this t, okay? So theta changes with respect to time, right? So similarly from equation number 5, what we have got, the amplitude is also a function of time, right? Amplitude, let me write it properly. Sorry, of the resultant vibration or wave changes with time. So here you see, here this is also function of t, so that's why it changes with time, right? So now you see, when you see, let me go back to the previous slide. So this result will be maximum when this part becomes equal to 1, when cos 2 pi nu 1 minus nu t, that becomes equal to 1, right? So for maximum amplitude, let me write here, for maximum amplitude, this must be equal to 1. Okay, now so what going to be the general solution for this to be 1? So that's going to be equal to 2n pi, right? 2n pi, right? Because cos n pi is equal to minus 1 to the power n. So if it is 2n pi, then it will be minus 1 to the power 2n. That's going to be always positive 1, right? Hope you have understood this. So here this n is equal to 0, 1, 2, 3 dot 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 so on, right? So in that case, if this is equal to 1, then the resultant amplitude A root over a square plus b square plus twice ab. So that means here these parts become 1, right? Now from equation number 5 we have got a is equal to this, which is going to be equal to root over a square plus, sorry, not a square, a plus b whole square, a plus b whole square. So a gonna be equal to a plus b. That's what we have got, right? So you see, this supposed to be cos of 2n pi. I have forgot to write this. Okay, so now you see, therefore this term must be equal to this term here. You see, 2 pi nu 1 minus nu 2 into t must be equal to 2n pi, right? So here you see, this 2 pi nu 1 minus nu 2 into t, this one must be equal to 2n pi. So the time when this amplitude will be maximum, that's going to be equal to t is equal to 1 by nu 1 minus nu 2. Okay, so this is the time and this is the maximum amplitude. Okay, when t is equal to this, that's what we have got, right? Oh, sorry, I forgot to write the n. Yeah, that's supposed to be n here. Okay, now here you see, for the value of n equal to 0, 1, 2, 3 dot dot dot, this value will be equal to 0, 1 by nu 1 minus nu 2, then 2 by nu 1 minus nu 2, and so on, right? That means at those instants we're gonna get maximum amplitude. That means at time instance 0, 1 by nu 1 minus nu 2, comma 2 by nu 1 minus nu 2 dot 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 etc. The amplitude, or let me write the resultant amplitude, the resultant amplitude will be maximum. Okay, let me write it properly. Is maximum, right? Hope you have understood this. Resultant amplitude to be minimum, the resultant amplitude to be minimum. Yeah. Okay, for minimum amplitude, this let me go back to this slide. Okay, from equation number 5, you see, this will be minimum when this quantity will be negative, right? And that will be obtained by taking this one equal to minus 1, right? Okay, so when this one will be -1. So let me show you. Now you see cos 2 pi nu1 minus nu2 into t, that will be -1 when we're gonna get 2n plus 1 into pi. This one will be -1 when when we take cos of odd multiple of pi, that means 2n plus 1 into pi, 2n plus 1 into pi, where again n is equal to 0, 1, 2, dot dot dot, so on. Because you see, because cos n pi is equal to -1 to the power n, if you take instead of n 2n plus 1, which is odd, then here also we're gonna get 2n plus 1, again that's gonna be -1, right? For odd power, that's gonna be -1, right? So here we can write that 2 pi nu1 minus nu2 into t is equal to 2n plus 1 pi. That's what we're gonna have, right? So in that case, the amplitude, resultant amplitude, will be root over a square plus b square. If we take this value is -1, then here we're gonna get -2ab, which is a minus b whole square, and square root of this is a minus b. That is the minimum resultant amplitude. And when it will occur, so from this relation what we can get, we will get t is equal to, so here pi will be cancelled, okay, t is equal to 2n plus 1 by 2 into nu1 minus nu2. That's what we're gonna have, right? So from here, but if you put n is equal to 0, 1, 2, dot dot dot, so on, then what we're gonna have here, on putting 0, we will get, if you put 0 here, 2 will be cancelled, right? Because you see, sorry, this will not 2. So if you put 0 here, this term will be 0, 0 plus 1, that's 1. You're gonna get 1 by 2 into nu1 minus nu2, right? Then if you put 1 here, then it's gonna be 3 by 2, right? So 3 by 2 into nu1 minus nu2, that so on, right? At this instance of time, you're gonna get minimum amplitude, right? So here you see, now you see, let's find the time interval between any two maxima or minima, okay, two consecutive maxima or two consecutive minima. So let me show you something. Here you see, so these are the instance where we get maxima, right? So if you take the difference of any two successive maxima, then you're gonna get the time difference is this one minus 0 will be again 1 by nu1 minus nu2. Similarly, in case of minima, if you take the difference of this one and this one, if you subtract this one from this one, then again what you're gonna get, 3 by 2 into nu1 minus nu2 minus 1 by 2 into nu1 minus nu2. If you subtract it, then 2 into nu1 minus nu2 will be the LCM, and numerator will be 3 minus 1. 3 minus 1, which is equal to 2 cancels. Again we're gonna get 1 by nu1 minus nu2 in this case also, right? So we can say that time interval between any two maxima, successive maxima or successive minima, is given by 1 by nu1 minus nu2. That means therefore the time interval between two successive minima or between two successive minima. Okay, so here I have written minima. Let me write maxima. Two maxima is 1 by nu 1 minus nu 2, nu 1 minus nu 2, right? And if you take the reciprocal of this time difference, time interval, then you're gonna get the number of bits per second. Okay, therefore number of bits produced per second will be the reciprocal of the time interval between any two successive maxima or any two successive minima. So now you see the time interval between any two successive minima or maxima, you can consider the here you can consider the frequency of bits, time period of bits. Okay, time period of bits. That means if you take the reciprocal of that, then you're gonna get the frequency of bits. Frequency of bits means bits produced per second. That reciprocal of this, that's gonna be nu 1 minus nu 2. So which is the difference in frequency, right? So that is what we needed to prove, right? So number of bits produced per second is equal to difference between the frequencies of the two waves. Okay, equal to difference in frequencies of the two waves. So hope you have understood this. So thank you for watching. See you in the next video. Bye bye.